Hey everyone. Okay, so today's example problem is going to be for solving multi-step equations. So last week we started solving equations. We had an unknown variable on one side of the equal sign. This time around, we are going to be having variables on both sides of the equal sign. So let's take a look at our word problem. It says, Brandon and Angelo were racing each other on the track. Brandon started at the 5-meter line and ran 4 meters per second. Angelo started at the starting line and ran 6 meters per second. When do Angelo and Brandon tie? So here I have some important piece of information. So Brandon started at the 5-meter and ran 4 meters per second. I'm going to highlight that important information. Angelo started at the starting line and ran 6 meters per second. So let's go ahead and highlight that important information. And I want to know when the two runners tie. That's my goal for when I solve. So over here, I have Brandon's information that I'm going to fill out first. So let's go ahead and do that. So Brandon started at the 5-meter line. So his starting point is 5 meters. And he is running 4 meters every second. So that is my constant rate of change. And then the last thing I'm going to do is, now that I know those two pieces of information, I can go ahead and write Brandon's equation. And I follow the same format, y equals mx plus b. So y equals, and then it's going to be 4x plus 5 in this case. And then I'm going to do the same thing for Angelo. It said that he started at the starting line. So since he started at the starting line, his starting point, that number is going to be 0 because he hasn't started before the starting line at all. So his constant rate of change, he's running 6 meters per second. So those are my two pieces of information, so I can write his equation. So Angelo's equation is y equals 6x. Now I could also put plus 0, but since I'm technically not adding anything, I don't have to put the plus 0 part. All right, so I have both of their equations. Now I need to figure out when they tie. So another word for tie that we've been using is the word intersection. An intersection means to cross paths, because if you notice, both runners do not start at the same point in the race. They're also running two different constant rates of changes here. So they're both running at different meters per second. So it seems as though both runners might end up tying or intersecting or crossing paths at some point of the race. So I'm going to set up my equations with, I need to know when Brandon is tied with Angelo. And we're going to use tie as an equal sign. So I want to know when Brandon is equal to Angelo in the race. And the way that I do that algebraically is I write Brandon's equation. So his equation is 4x plus 5, and it's equal to Angelo's equation, which is 6x. Okay, and if I move these out of the way, I can actually see the algebra tiles in the picture of that setup. So I have 4x's plus 5 equals 6x's. All right. So if you notice, now that I have x's on both sides of the equal sign, okay, and then I have these 5 ones over here. So since I have multiple x's on both sides, that's usually probably my first go-to, that I am going to be moving some x's, because I can't have x's on both sides of the equal sign. I need to have all the x's on one side, because the point of solving is to make sure that I am solving for one x at the very end of this. But it looks like I have a bunch of x's. So algebraically, what I would do is I'm going to have to zero these 4 x's out. That way I can move my x's over here. Well, if these are positives, how do I zero out positive x's with negative x's? So Control C, 1, 2, 3, 4. Now I have 4 x's that I need to zero out. So I'm only going to make 4 x's, or 4 negative x's, I guess I should say. Okay. Now, what I do to one side, I also have to do to the other. So if I added 4 here, 4 negatives here, I have to add 4 negatives to the other side as well. So now let's write what we just did. Okay. So I added negative 4x, not just negative 4, but negative 4 x's. And notice that when I added in the picture with the algebra tiles, I did not add those with the 5 positives. So when I write this, I cannot put minus 4x underneath the positive 5. So I'm just going to backspace and kind of just move that over here. Okay. Now I added it to these positive 4x's, but I also added the negative 4x over here. And in this case, I did add them to the 6x's. So I am okay to go ahead and type negative 4x. Okay. Now I'm about to get a new equation, so I'm going to use this line to kind of separate. And let's see. So I have 4x and then minus 4x's. So these end up making 0 pair. So I'm going to go ahead and cancel those out by taking them off. And all I'm left with is the positive 5. So let's type what that kind of looks like here. So I have a 0 pair plus 5 left over. I'm going to move those over. Okay. And then I'm going to look over to the right side. I did end up making 4 0 pairs, so I can do the same thing. These are now making 0, so I'm going to cancel by moving them over. And all I have left on the right-hand side are 2 x's. And I can see that algebraically because, well, 6 minus 4 equals 2. Okay, so here's my new equation. 0 plus 5 equals 2x. Now, since I'm not technically adding 0 to 5, really I could just write this as 5 equals 2x. So at this point, my equation should match what my algebra tiles show. All right, so now I know that it's 5 meters for every 2 seconds. Now I've got to figure out, well, how much for 1x? So what I would do is I'm got to separate these two into equal groups. So looks like I only had 2 x's, so I only had to make 2 equal groups here. Okay, so then what I'm going to do is I'm going to split my 1's also, because what I do to one side, I have to do to the other. So I have to split these up into equal groups. So 2. And it looks like there's going to be this one kind of piece left over here. And so we're going to see. So I know 2 of these 1's fit into each group, but then I have this one here. So what I could do technically is I could kind of split this in half, right? And let me make that line bigger so I know I split that in half. I could split that in half and say, oh, well, half of that one would fit in here and half of this one would fit in here. So let's see what that actually looks like algebraically. So when I split the x's and the 1's into 2 equal groups, splitting means to divide. And I divided into 2 groups, so I'm dividing by 2. So to show division on here, you highlight what you're dividing and you press this U for underline, and that shows the fraction bar. So that tells us that you are dividing. So I divided the 2x into 2 groups, but I also divided those 5 1's into 2 groups. So I'm going to show divide, and then I divided into 2. Oop, don't need that one because I'm not dividing the 2. Okay, so I'm going to put that over here under the 5. All right. So I'm about to finish up the equation, so I'm going to put this line here again to help me stay organized. And now let's look at what we have here. So I took my 2 x's, I divided into 2 groups. So in each group was only 1 x. And I took the 5 1's and I divided into 2 groups. And let's see, I am left with 2 and a half. 2.5. And I could see that here if I took my calculator. If I just took 5 divided by 2, I get 2.5, which is 2.5. So Angelo and Brandon end up tying at 2.5 seconds. Okay. So this is how we solve multi-step equations. Make sure that you have picked out the information from the word problem. That was the first step, right? We had to find the starting point and the constant rate of change. We also had to make sure we wrote the equation down for each person. And then on the algebraic side, I went ahead and wrote their equations down. And then I solved using my algebra tiles to help match my algebraic side. If you have any questions, go ahead and email your teacher. We will be glad to help.